Hello everyone. Today we will be continuing our discussion of apportionment with what is known as Jefferson's method. Now, Jefferson's method falls into a category of apportionment methods that we refer to as divisor methods. And these basically are apportionment methods that rely on adjusting the standard divisor until we find a divisor that basically allows us to apportion every state, either its upper or low, or modified upper or lower quota, without having any excess or seats or falling short. So Jefferson's method basically relies on having a modified divisor that we divide all of our populations by to get modified quotas, and then giving every state its modified lower quota. Now, as you can see, I have written on here the standard quota and standard lower quotas for all of these states. And if we use the standard divisor of 1,000 and basically calculate the lower quotas based on the standard quotas, we end up with a total of only 97 seats. So the way that we sort of work around this with Jefferson's method, in contrast to Hamilton's method, which basically just takes the remaining seats and assigns them to states based on the residues, what we're going to do is we're going to adjust the divisor so that we don't have extra seats basically to assign. So at this point, we are going to guess a new divisor. These divisor methods use more or less a trial and error process. So what we're going to do is we're going to pick a lower divisor than 1,000. That way these numbers all go up basically, and ideally we'll find something that gives us a total of 100 when we do lower quotas for everything. So let's guess a divisor of 975. So lower than our standard divisor of 1,000. Now, what we're going to do is we're going to divide all the populations by 975. There's a few ways that you can kind of speed this process along. If you have a graphing calculator or something else, some other kind of calculator that can do list functions, this is a very helpful way of doing this. I like to give my students an Excel template that they can use when they're working on homework assignments or whatever that will do a lot of these calculations as well. So if we put this into our calculator, divide all of these by 975, then we get modified quotas of 5.03, 32, 39.59, 16.1, and 9.85. So now what we're going to do is we're going to round all of these down to the lower quotas and see how many seats we have given out by doing that. So this would be 5, 32, 39, 16, and 9. So if we add all of these up, we get 101. So what this basically means is that we have overshot what we need in order to get 100. So we've gone too far below 1,000. So we're going to try another value that's in between. Since we were closer with this one than we were with our original 1,000, we're going to try something that's a little bit closer to 975. So let's try 980. If we put that into our calculator, then we get 5, 31.84, 39.39, 16.02, and 9.8. All right, and if we round all of these down to the lower quotas, that gives us 5, 31, 39, 16, and 9. If we total all of these up, that gives us 100. So this is how we would solve an apportionment problem using Jefferson's method. Sometimes these problems can be a little bit finicky with what divisors do and don't work well. That's why I recommend using list functions on your calculator or Excel to speed things along if you have that available to you to do so. Thank you for watching, and as always, feel free to let me know if you have questions.